Right now, the silence of the Kootenay Valley is being overwritten by the roar of 500 cubic meters of water per second. It is 3:42 p.m. on Sunday, April 12, 2026. At the Arden Crossing Lock and Dam complex in British Columbia, the water is no longer just a resource, it is a weight. Everyone hears the phrase dam emergency and thinks the same thing: too much rain, too much snowmelt, too much water. And they are right. Right now, the reservoir level is climbing toward an evacuation trigger that will displace 7,000 people in the valley floor. But the crisis isn't just the volume of the inflow, it is the silence of the turbines. While the Arden hydro station, a critical component designed to move massive volumes of water through its generation tubes, remains offline, the main spillway is fighting a losing battle against the physics of a record-breaking spring freshet. At Arden Crossing, there is a published, cold-blooded protocol for what happens as the reservoir climbs. At 30 centimeters from the crest, residents start packing. At 15 centimeters, they prepare to leave. At 2.5 centimeters, the evacuation order is no longer a warning, it is a command. As of this Sunday afternoon, the water is precisely 38 centimeters from the crest. The dam is moving toward its threshold, while the very system that should be relieving the pressure is mechanically paralyzed. From a distance, this looks like the usual spring emergency picture in the Canadian interior. Record snowpack in the Selkirks, 3 days of a relentless Category 4 atmospheric river, and water levels rising across the entire Columbia River Basin. Public Safety Canada has activated the Regional Emergency Operations Center. Thousands of sandbags have been deployed by BC Wildfire Service crews, redirected to flood duty. Heavy-duty pumps are humming, and Environment and Climate Change Canada, ECCC, has issued its highest-level flood warnings. But the water keeps rising anyway. The Arden Crossing complex is not just the locks and the gates the public sees. Tucked beside that BC Hydro managed structure is a privately held generation station. And that station matters for one simple reason: it moves water. In an emergency like this, moving water is not a side issue, it is the entire objective. But as of April 12th, that generation station is not operating. Officials from the Provincial Ministry of Forests and Natural Resources Canada indicate that while some water is escaping through bypass valves, these are not a substitute for a working hydro station adding real flow capacity while the reservoir is under extreme hydraulic pressure. When the province says they are pushing through as much water as they can, it does not mean the system's design capacity. It means the capacity they have under the conditions of a mechanical failure. That is a very different sentence. This is not simply a dam taking on too much water. This is a dam facing a 1 in 100-year inflow at the exact moment its primary safety valve, the hydro station, is crippled. The real question is no longer the rainfall totals. It is how much usable margin is left when the system is not operating at full flow capacity and the water has no place else to go. At 7:22 p.m. on Sunday, April 12, 2026, the automated monitoring array at the Arden Crossing complex began to transmit a sequence of data that shifted the situation from a high-flow event to a structural crisis. High-precision GNSS sensors mounted directly onto the crest of the northern earthen embankment recorded a 14 mm horizontal displacement toward the downstream face. In the world of dam safety, 14 mm is not a measurement, it is a scream. This displacement suggests that the internal core of the dam is no longer resisting the relentless hydraulic head of the reservoir, it is yielding to it. Simultaneously, vibrating wire piezometers, sensors buried deep within the dam's foundation to measure water pressure, reported a pore pressure spike that exceeded the 1 in 500-year design threshold. This is the geophysical reality of a coupled system in failure. The Kootenay region had already seen a 240% increase in average April precipitation, but the danger isn't just the rain. It's the weak layer chemistry of the British Columbia interior. Beneath the Arden crossing structure sits a complex stratigraphic sequence of glaciolacustrine silts and clays, remnants of the last glacial retreat. When these layers become oversaturated, they lose their shear strength. They don't just get wet, they turn into a lubricant. Dr. Elias Stone, a senior geotechnical researcher with the Geological Survey of Canada, GSC, released a preliminary assessment at 9 p.m. that underscored the gravity of the situation. The saturation levels in the Kootenay Basin have reached a state of total liquefaction potential. The Arden crossing structure is currently acting as a massive hydraulic piston, driving tens of thousands of tons of pressure into a foundation that has the consistency of wet flour. We are no longer monitoring a water management event. We are monitoring a structural deformation event. As the sun set on April 12th, the clock-is-ticking tension escalated. The reservoir level was now 28 centimeters from the crest. At the Ministry of Water, Land and Resource Stewardship, the telemetry showed that the inflow from the Purcell Mountains, fueled by a rain-on-snow event, had surged to 1,200 cubic meters per second. To put that in perspective, the primary spillway and the lock system can only bypass 950 cubic meters per second at maximum safe velocity. The remaining 250 cubic meters have nowhere to go but up, eating away at the final inches of the dam's freeboard. This is where the offline Arden North hydro station becomes a fatal variable. If those 340 megawatt turbines were spinning, they could draw an additional 300 cubic meters per second directly out of the reservoir forebay. That capacity would have effectively neutralized the inflow surge. But the station remains dark. A regulatory deadlock over a turbine refurbishment certification, combined with a late-stage mechanical failure in the bypass gate's hydraulic hoist, has rendered the most powerful tool in the regional arsenal useless. The Provincial Emergency Coordination Center, PECC, in Saanich is now receiving minute-by-minute updates from Natural Resources Canada seismologists. They aren't looking for earthquakes, they are looking for harmonic tremors, the specific vibration signature of water piping through the internal structure of the dam. If the water begins to carve a path through the interior silts, the dam will fail from the inside out in a process called internal erosion. At 11:45 p.m., the first reports of cloudy water appearing in the downstream tow drains arrived. In dam engineering, cloudy water is the ultimate red flag. It means the dam is literally being washed away from the inside. The broader water system is screaming. Environment and Climate Change Canada has expanded the flood warning to include the entire Kootenay River loop, from the headwaters down to the Arrow Lakes. The water is still rising. The turbines are still silent, and the GNSS sensors just recorded another 4 millimeters of movement. To understand the scale of the threat at Arden Crossing, one must look at the ghosts of Canada's hydrological past. Michigan's 2020 Edenville disaster is often cited by engineers, but for British Columbia, the shadow is cast by the Great Flood of 1948 and the 1996 Saguenay catastrophe in Quebec. In 1948, the Columbia and Kootenay rivers rose with a ferocity that obliterated towns like Micaville and displaced 16,000 Canadians. It was a disaster born of the same coupled system we are seeing now, a massive winter snowpack followed by a sudden, unseasonable heat wave and a relentless atmospheric river. The science of 2026, however, adds a lethal modern twist. Analysis from the University of British Columbia's hydrometeorological lab suggests that for every 1 degree Celsius increase in atmospheric temperature, the air can hold 7% more moisture. This is the Clausius-Clapeyron relation in action. The storm currently parked over the Selkirk Mountains isn't just rain, it is a moisture conveyor belt delivering trillions of liters of water directly into the Kootenay catchment. This brings us to the terrifying concept of usable margin. A dam is a machine designed to balance two numbers, inflow and outflow. When the outflow, consisting of the spillway, the lock bypass, and the hydro turbines, is less than the inflow, the reservoir becomes a ticking clock. At Arden Crossing, the math is failing. Because the privately owned hydro station is offline, the physical margin of the dam is being consumed at a rate of 2.1 centimeters per hour. Historical data from the Geological Survey of Canada confirms that this region sits atop a complex network of tectonic microfaults associated with the Rocky Mountain Trench. While these faults are generally stable, the sheer weight of a bloated reservoir, billions of tons of extra hydraulic load, can trigger induced seismicity. We saw this in the 1960s during the filling of large Canadian reservoirs. If a localized tremor were to strike now, with the dam's foundation already saturated to the point of liquefaction, the result wouldn't be a leak. It would be a static liquefaction failure. The 1996 Saguenay flood remains the definitive Canadian warning for this exact scenario. In that event, 10 small dams failed, and several larger ones were overtopped because the spillway capacity simply could not keep up with the sky's output. The resulting wall of water and debris caused $1.5 billion in damages and permanently altered the landscape. At Arden Crossing, the debris factor is already becoming a variable. Upstream, the BC Ministry of Forests has reported dozens of debris flows, landslides carrying old-growth timber and glacial till slumping into the reservoir. This material doesn't just fill space, it clogs the trash racks of the remaining functional spillway gates. As of 1 a.m. Monday, the water is no longer just rising, it is changing consistency. The turbidity sensors are showing a massive spike in suspended solids. This means the water hitting the dam is denser, heavier, and more abrasive. Every cubic meter now carries the kinetic energy of a battering ram. Forecast models from Environment and Climate Change Canada suggest the peak of the freshet is still 48 hours away. But the most alarming data comes from the dam's galleries, the internal tunnels where engineers monitor the structure's health. At 2:15 a.m., crews reported uplift pressure readings that have gone off-scale. In simple terms, the water is trying to lift the dam off its foundations. This is the two-clock problem. The atmospheric clock is moving toward a peak, while the mechanical clock, the effort to restart the hydroturbines, is stalled in a loop of diagnostic errors and regulatory red tape. If the Arden North turbines do not spin within the next 12 hours, the reservoir will reach the level 3 evacuation trigger. This isn't a hypothetical model. It is a calculation of concrete, gravity, and the relentless expansion of a river that has run out of room. The question isn't whether the water will hit the crest, it's whether the dam will still be standing when it does. At 3:15 a.m. on Monday, April 13, 2026, the digital silence of the Arden Crossing control room was broken by the sharp rhythmic pulse of the level 3 evacuation alarm. The water had reached 1 centimeter from the evacuation threshold. For Sarah Chen, a senior hydrologist with the BC River Forecast Center, the numbers on her screen were no longer abstractions of fluid dynamics. They were a death warrant for the lower valley. "We have lost the buffer," she recorded in the official incident log. "Inflow remains at 1,240 cubic meters per second. Spillway capacity is capped. Without the hydro station, we are now entirely dependent on the structural integrity of a saturated embankment that is moving 2 millimeters every 4 hours. The clock has run out." Outside, the valley was a hive of controlled panic. Under the coordination of Public Safety Canada, the evacuation order was broadcast via the National Public Alerting System. In the town of Creston Arden, the sound of sirens competed with the low-frequency thrum of the river. Alistair MacLeod, a third-generation cherry orchardist whose family had farmed the Kootenay Flats since the 1920s, watched from his porch as the first RCMP cruisers began their door-to-door sweeps. For Alistair, this wasn't just about property, It was about the 4.2 million Canadian dollars in specialized equipment and the century-old trees that represent the backbone of the regional economy. The river is different this time, Alistair told the local news crew as he loaded heirlooms into his truck. In 48, it was a slow rise. You could see it coming for weeks. This is like the mountain is trying to push the water through the valley all at once. You can feel the ground vibrating through your boots. It's not a flood, it's a siege. The logistics of the evacuation were a nightmare of Canadian geography. Highway 3A, the primary artery through the region, was already suffering from scouring at the bridge abutments. By 4:30 a.m., the BC Ministry of Transportation and Infrastructure was forced to close the Kootenay Lake ferry service due to extreme debris in the water, effectively cutting off the western escape route. This left the southern transprovincial highway as the only lifeline, a road now choked with thousands of vehicles, livestock trailers, and emergency equipment moving in the opposite direction. The CPKC rail line, a critical corridor for Canadian trade, was officially suspended at 5 a.m. after sensors detected track subsidence near the Arden crossing spillway. Every hour the line remained closed cost the Canadian economy an estimated 12 million Canadian dollars in stalled shipments of grain, potash, and lumber. Deep inside the Arden North Hydro Station, Nadim Al-Fayed, the facility's lead mechanical engineer, was engaged in a desperate technological war. The station was a tomb of cold steel and stagnant water. The problem isn't just the turbines, Nadim explained via satellite link to the Provincial Emergency Coordination Center. The hydraulic governors that control the wicket gates are unresponsive. We are seeing a total synchronization failure between the private grid and the BC Hydro backbone. We have the flow capacity, but we lack the permission from the hardware to open the gates. It's a digital lock on a physical floodgate. Nadim and his team were working by flashlight, the station's internal power having been cut as a precaution against a catastrophic short circuit. The air was thick with the smell of ozone and damp concrete. They were attempting a black start bypass, a high-risk procedure to manually force the intake gates open without the electronic safety interlocks. If they succeeded, they could vent enough water to stop the rise. If they failed, they risked a mechanical water hammer that could shatter the penstocks and turn the hydro station into a secondary point of failure, potentially accelerating the collapse of the main dam. By dawn, the estimated damage to infrastructure was already staggering. Public Safety Canada's preliminary models suggested that a full breach of the Arden Crossing Dam would result in a dam break wave 15 meters high, traveling at 30 kilometers per hour. This wall of water would not just flood the valley, it would erase it. The projected economic impact was revised upward to 2.8 billion Canadian dollars, including the total destruction of the Arden Creston Industrial Park and the permanent loss of the region's agricultural topsoil. But the ecological toll was even more grim. Upstream tailings ponds from legacy mining operations were now at risk of being overtopped. A breach would send a plume of heavy metals and arsenic into the Kootenay River system, threatening the habitat of the endangered white sturgeon and poisoning the water supply for communities all the way to the Arrow Lakes. For the Ktunaxa Nation, whose ancestral lands encompass the entire flood zone, the emergency represented a threat to cultural sites that have survived for millennia. Elder Mary Runningbird worked with Parks Canada and local volunteers to send back a 4,000-year-old archaeological site near the river confluence. "This river is our mother, but the dams have made her a prisoner," she said. Now the prisoner is trying to break free, and she doesn't care what stands in her way. We are fighting to save our history, while the modern world fights to save its machines. As the sun rose behind a thick veil of grey clouds, the water at Arden Crossing was no longer 1 centimeter from the crest. It was level with it. The first waves began to lap over the concrete parapet, sending thin ribbons of white foam down the downstream face of the dam. The 2 o'clock problem had reached its midnight. The water had arrived, and the machinery was still silent. In the distance, the first low rumble of a shifting embankment was heard, a sound that seismographs at the GSC would later identify as the beginning of a catastrophic shear failure. At 6:14 a.m. on Monday, April 13, 2026, the Arden crossing complex entered the terminal phase. The water was no longer just lapping over the crest. It had established a continuous sheet of overtopping flow across a 40-meter section of the northern earthen wing. In the cold physics of dam failure, this is the point of no return. As the water crests an embankment, it gains velocity on the downstream face, stripping away the protective riprap and beginning a process called head cutting. Once the water begins to eat into the core of the dam from the backside, the structure's remaining life is measured in minutes, not hours. But then, a mechanical miracle, or perhaps a desperate gamble, intervened. Inside the Arden North Hydro Station, Nadim Al-Fayed's team successfully bypassed the failed digital interlocks. At 6:22 a.m., turbine number 2 groaned to life. The vibration was so intense it was picked up by GSC seismographs 50 kilometers away in Nelson. Seconds later, turbines 1 and 3 followed. The roar of the water being sucked through the penstocks was a visceral change in the environment. Suddenly, the system was moving an additional 310 cubic meters per second. The reservoir level, which had been rising for days, hesitated. For the first time since the storm began, the outflow exceeded the inflow. The overtopping stopped. The physical margin was clawed back, centimeter by agonizing centimeter. By 10 a.m., the water had dropped 15 centimeters below the crest. The immediate catastrophe of a total dam break wave was averted, but the cost was visible. The northern embankment was scarred, its downstream face gouged by deep erosion gullies. The dam had survived, but it was no longer the same structure. It was a wounded asset. The 2026 Arden crossing incident was not an isolated event. It was a diagnostic of a much larger systemic fragility within Canada's national infrastructure. A post-incident report by the Geological Survey of Canada, GSC, and the National Research Council, NRC, titled The 2026 Kootenay Hydrological Crisis, a study in coupled system failure, identified a chilling trend. The report noted, the Arden crossing event demonstrates that our monitoring protocols assume a static landscape that no longer exists. The coupling of extreme atmospheric river events with aging mechanical systems and geologically sensitive foundations creates a cascade effect, where the margin of safety is an illusion. The data for the coming decade, from 2027 to 2035, suggests this was merely a dress rehearsal. As the permafrost in the high Selkirks continues to degrade, the geotechnical stability of the entire Columbia River Basin is changing. We are looking at a future where glacial lake outburst floods, GLOFs, and record-breaking freshets are the new baseline. Consider the implications for the rest of Canada. The St. Lawrence Corridor, a system of aging locks and dams handling 60% of Canada's maritime trade, facing increased isostatic rebound stresses. The prairie reservoirs, massive earthen structures like the Gardiner Dam, where poor pressure management is becoming a year-round battle against shifting soil horizons. The Arctic energy frontier, new infrastructure being built on permafrost that is no longer permanent, creating a foundation of shifting slush for multi-billion-dollar Canadian dollar investments. The real story of Arden Crossing isn't that the dam held, it's that it nearly didn't. It revealed the widening gap between the speed of nature and the speed of bureaucracy. The hydro station sat idle during the peak of the crisis, not because of a lack of water, but because of a lack of regulatory synchronicity. The two clocks, the water and the system, must be synchronized, or the next event will have a different ending. In the aftermath, the BC Ministry of Finance estimated the recovery and hardening costs for the Kootenay-Columbia Basin at 1.4 billion Canadian dollars. But money cannot buy back the sense of security for the 7,000 people who sat in their cars on Highway 3A watching the crest of a dam that was failing in real time. As we look toward the 2030s, the data is unequivocal. The 1 in 100-year flood is now a decadal event. The standard engineering model is being rewritten by a landscape in transition. We are moving from an era of water management to an era of disaster mitigation. The usable margin is shrinking across every province and territory. At Arden crossing today, the turbines are spinning. The water is low. The scars on the embankment have been patched with fresh concrete and reinforced riprap. But the GSC sensors remain active, transmitting a constant stream of data back to Ottawa. They are watching for the next tremor, the next atmospheric river, the next pore pressure spike. Because in a coupled system, the next emergency is already in the ground, waiting for the right moment to surface. The water always finds the path of least resistance. The question for Canada is whether our infrastructure will continue to stand in its way, or if we are simply building the monuments of a future we can no longer control. If this analysis of the Canadian landscape matters to you, subscribe. We track the data, we follow the tremors, and we map the inevitable. This is not just geology, it is our future. Follow the data.